use through these training sessions. And then we'll move to the modules. First module, I would cover how we can import the data and export the data in R. And then we will see how we can do data transformation and also data manipulation so that it can help us through our downstream data analysis. And the third module that I will try to cover is through this session is how we can do some exploratory data analysis, very basic ones. And fourthly, I'll show the data visualization techniques, just very basic ones. So firstly, what is the basics of data science and why we want to use R for that kind of projects? So if I go briefly with the data science lifecycle, for any data science projects, we start with the domain knowledge. First, we need to understand what type of projects that we are trying to conduct, what are the problems at hand, what are the analyses we are needed. So we need to acquire all the knowledges, all the background knowledges as much as we can so that it can help us in our further analysis. Secondly, we need to import the data. The data import can be done in many ways. It can be done from importing from files, importing from live streams. And there are various challenges in importing the data, basically, because the data types are different. They are structured, sometimes they are not structured, sometimes they are semi-structured. So there are a couple of challenges are there when we are going to load the data. So importing means the loading the data in our R. And the next thing is that, okay, when we are importing the data, still it is not ready to do our desired analysis. So we should do some cleaning, we should do some reshaping that can help us through our project. So that's why the basics, which is the first step, it will guide us or it will hypothesize us what sort of cleaning we should do so that it can serve our purpose. Next is data exploration. I mean, how we can see the data. So we need to feel the data basically. For the desired purpose, whether the data are really in a proper shape or not, whether we need to do any kind of modification in the data, what type of variables are available, and so on. We're just exploring it. We are not analyzing it properly. We are just hovering around the data by observing different variables and all that, whether there is any missing information or all these things. Next thing is feature engineering and predictive modeling. These are advanced things which needs us to understand different types of statistical and machine learning on AI or AI models, so that it will help us to do smart things out of this project. So these are the advanced topics. And finally, data visualization. We need to show our audience that, okay, after all these hard works that we have done through the data analysis, this is the result I've got. This is the outcome that I achieved. This is the hypothesis that I'm trying to provide through the communication. So data science lifecycle is vast and it covers a lot of steps as a whole. But why we are using R for that purpose, for this journey? Well, because there are many reasons. What R is now I'm just picking 2 points here to say or to advertise why R is important for data science project. Number one, it is state of the art now. It is having a lot of package and libraries and a lot of community helps available. And second point, which is the most important thing in my opinion, is that R is a language that is inbuilt, has some intelligence. We will see different libraries, different data structures, which will allow us to seamlessly run through the data sets, seamlessly run through their logics. It will make our process very much simpler. It is very advanced, as we can say. So it's a language that is by itself, it's an intelligent language, which we will see later on. So what sort of technologies that we can use in order to run our R codes? Well, the very popular one is RStudio. I'm sure you have heard of it, RStudio. It is free for the local running. You can download this from posit.com. When you install it, you see this type of interface. And R is basically, it is run through 2 ways. One is the console-based one. Another one is, you can create a file, source file, and then you can run it. So here I'm showing you a Hello World program, which is the first program that you can do for any programming language. But R basically it started with a statistical programming language, but later on it has evolved so much so that it has become a status quo for data science projects. So here we can just simply type print as a command, and you can just quote a double quotation here, hello comma world, just to print out what's the outcome. And our outcome is going to be hello world as it is. You can see it's simply just one liner compared to C or other mid-level programming languages. They need you to write out 5 or 6 lines to just print out this hello world. Now, just compared to that, it is just like one liner. So here in this interface, you can see the environments, what are the variables are available in this kind of session, and this is the component where if you just plot any figure, it will show up here. It also have helps and other tabs available for helping you throughout this project implementation. In order to do some sort of works, we need to get help from inbuilt functions, and those functions are already been developed by other researchers, and this is called packages. So those packages are already developed. All you need to do is just to install them through this command, install the packages, and in comma you put out this package name. So these are the case sensitive words. You remember the capital D would mean different things. So we should be careful about the cases in this word. So when you install them, it will be installed in your machine, but it is not loaded to your session yet. So you need to load that through this library command. So this is a function, basically. Any function has a bracket that it starts and ends, and inside you put some sort of input in that function. So dplyr is the package that you have just loaded. Remember, you can directly put out the word, or you can put inverted comma. Both works. As I said, it is very intelligent language. It can work. It can accommodate any sort of deviations that it can understand. So you can just put the word dplyr with a library function, and it will load this into your session. And when you want to use some function through this package, so dplyr : and the function name, and you can mention them, and then in a bracket you put the comments or the inputs that for that function, so that you can use or exploit that function. And sometimes some data sets are already inbuilt with the package. You don't need to import it. So these are some model data set. You can say the model data set are going to be available through this command. So you can put data as a function, and you put the data set name. So this model data set has some name. ID is one of the popular data set available in data science projects. So you can just import them, and you can analyze and you can showcase your codes through those data sets. Anytime you need any help for this function, you can just type comma, this question mark, and then you put the function name. You can get help in this help tab, so the help will be available. And also, there are some functions available to explain the summary of the overall object. So if R is a data object, you can put str. It will show you the detail of the data set, how it is organized, what are the value sets available for that. Class is the type of the data set. Is it a data frame, or it is a list or a character? Whatever it is, it will show you when you put the class. It is very handy function to observe. Very important to understand where I'm actually working. Get WD indicates get current working directory. So you sometimes need to find out the directory where this current code is working. So you need to print out that. So if you give this function as an input, it will show you the current working directory. But sometimes you need to modify that working directory. You need to tell R that, okay, now you work from this particular path. So you specify the file path to the set working directory function, and it will work from there. Very importantly, because it's a data science project, you need to understand the data structures. That's the heart of all the data science projects. So I will not go through the details, but I will just handpick some of the data structures that we will use. Vector is one of them. Vector is collections of numbers or objects. You can see. We will see in this detail about this type of lists or this type of objects or data structures when we do the programming exercises. But if you want to create any vector, you just put C, a bracket, and all the numbers that you are putting to make a vector. So the vector will be created as a data structure. and you will save it in a variable, just like in a matrix. When you create a matrix, you put a data from where this matrix will be constructed, number of rows, number of columns you need to create, and that will be saved in a variable called m. And later on, you can select a particular row by putting a row index here, and this comma, and the second one will be column index. And you can even particularly select a element by putting the column and row index in this manner. List is a very important data structure where you can create an array of different types of data set. Here vectors are just one type of data set you're putting because they're all numeric, but here you can group numeric and also their also character type of data as well. It is very important data structure for data analysis. Here you can put X is just as a level, so there can be named structure. That means we can put some name there, and then this vector will be created with its own name. So X will have a list inside there, and that will have a name X, and Y will have another structure, another list, which also will be named as Y. And when you print second element, we will see the A and B only, and you can also select the data structure by its own name, the first one X only. So it will see, you can individually observe or select the data structures there, in a nested data structure there. String is a data structure where you can put character arrays, just like names or other things. You can merge different strings by using paste command. And you can convert string cases to lower or to upper. You can count the number of characters there. Factor is a data structure that helps to organize the data set or data values that are grouped based on the characters, so that when we are going to use it for some group based analysis, for group based visualization, we can use the factor data structure accordingly. And the mostly important data structure is data frame, which is very flexible, and we can create a data frame through a data frame is basically a tabular form, it's a generic tabular form where you can have a column and we have a row. The column headers are named as this X and Y, and the rows are like the values that we are creating, 1, 2, 3. So 1:3, it will be indicating a list, just like we have seen here, or vector, just like we're seeing. It will be like 2, 3, 4, 5, 6 until all this number. So you can just specify first number and the end number. A sequence of number will be created automatically, just like here. And the Y is the second column where you are individually putting A, B, C. Even you can put A:C, it will automatically stress until from A to C. Like we have seen in the matrix case, you can even select the second column by specifying this first one empty, comma, second one as 2. It will show you second column. The one important point in R is that R is 1-based indexing, not 0-based. That means the first element that you should provide is 1, not 0. Unlike other programming languages like Python or C or other languages, they are 0-based. That means for any list or an array, you start from the 0 as an index. But here in R, it is 1-based indexing. It is very important to remember that. And you can print number of rows, number of columns, even the dimensions of the whole data set just by calling these functions accordingly, and pass the data set name or data frame name. So when you create the data frame in this way, you save that in the variable called df, and you can use those things, use that data frame by using this variable name later on. And you can see the data, the full data, by using the view command, and the head function will be giving you the first 6 lines or first 6 rows of the whole data set. So it is very important to observe initially what data frame contents we have, and you can even customize this head function by specifying the number of lines you need to observe. So here by default 6 rows will be shown. Now, just quickly, how we can do variable assignment. So let's say A is a variable, and I'm going to make it a string variable. So I am passing a string value by putting a single quotation or double quotation. Both works. So A would be a string, and I'm saving that as an apple as a value. And when I want to observe that value, I simply type the variable name and it will show me the content of the variable. Sometimes we need to convert the data types from one to others. For example, if we have 101 as a vector and we want to convert them to logical variable, so 0 value will be converted to false, and any other value will be converted to true. So if we put 201, still it will be true, false, true. And we can even convert them according to their values. So here numeric value can be converted to a character. It will automatically work for you. Secondly, when we are going to do some conventional programming through R, for example, the loops and also the if-else statements, these are very conventional process. So if you have any prior experience in other languages, you could relate yourself with these syntaxes, that they are not so much different. So you have a for as a syntax, and you put an iterative variable, and you have a sequence of the indexes that you want to go through, and you can do customize your line inside here, what sort of tasks you can do perform here. So for example, I is my iterative variable, it starts from the first and until 4. So this loop will start from 1 until 4. It will run for 4 iteration, and you just want to see the values. You just print the values, that is, we jump 10 steps. And if you want to do some logics like if-else based syntax, so you can put the condition here, the condition that will allow your code to go inside this if statement. If this is true, then it will go inside and it will perform your actions. If it is not true, then you'll go inside the else situation. Sometimes you need to do the functions. You need to define your own functions. For example, I want to make some function that will give me square. So the way you can do it is you just write a function name here. It is slightly different than other programming languages to define the function. So you have function name here, and this function is a syntax. This is a default word. R will understand that you are writing a function called square, and you are passing a function argument, a parameter. You will listing them as x will receive a value when you are calling this function square, and it will make a squared of this, and it will save it to squared variable, and it will return it. This is a very basic way of outlining how the function is written. And then if you want to read some table or read some data through a file, you can read that through our read.table function. As I said, some functions are already mentioned in some packages, and some packages are already implemented or already loaded when you load your R session. So for those functions, you don't need to install them. They are already there, or you don't even have to load them. The read.table function is one of such functions that are already available in some packages that are already loaded when you load your R session. So these functions you can just straight away call it, and you don't need to wonder where this function is coming from. Do I need to define it by myself or not? No, these are already loaded in your session. And for that, it's very important to familiarize yourself which functions are available for which package and which are not. So which can be done via checking the help pages. Like, for example, I don't know which functions are already loaded or which functions are not available here. I need to install it. So you just type it here. If it is coming up as a help, it is loaded already. That means it is installed in your directory. Otherwise, you need to install it through downloading from online databases. So if it is once you are calling this function with the file name, this is the file name. Sometimes you need to provide the path for it, and you load that data, and it will be saved as a df variable. So df is just a variable, and this word df, it is very common, a common variable name for using our analysis. So don't think that this is just like some reserved word. No, it is not a reserved word. It is just a word that you can even put your own variable name, no problem. And sometimes you have already done some analysis and some data frame, you need to save it in your file, which is your persistent storage. You can save them, the data value that you are using here, and then you are providing which file name you want to use for saving your data frame here. Read.csv is another similar function, but it is just saving CSV files, and write CSV is accordingly saving the files or saving the data frame in CSV files. Sometimes some data sets are already R-based, so they are called R data. You need to load them through load function. Sometimes you can save them in a save format. Some logics that we need to use for logical statements. So we need to check whether two things are equal or not. We need to provide double equation to check whether not equal or not. So you put exclamation and then equal and so on. Greater or less, smaller. This the way you are comparing A and B, whether A is greater or B or not. Accordingly, we are using this. Lastly, is NA. It indicates that whether the variable A has any missing value in there or not. Missing value in R is represented by NA. And whether if something is null or not, you can just check is null. So this function, it is a function, and it will return true if A has something missing. It will false. That means it doesn't have any missing value. And accordingly, is null function does the same thing for the case of null. So now I would quickly go through the training modules that we have designed for this training session. As you know, we have introduced RStudio for you. The RStudio is something that you need to download it, and RStudio here, it will take some time to install it. So why for that purpose, I'm going to use Google Colab, which is like interface that is readily available. You need to have a Google account for it, and all you need. In fact, Google Drive you have to have. So when you're going to go Google Drive, I'll quickly show you how we can open a new Google Colab interface. And we have a main notebook URL in Google Colab. This is the link we have. And also I have posted everything in GitHub as well. Maybe GitHub is not available through our university network. When you're going home, then you can observe the GitHub repository, but both of them are hosted in a hosting similar thing. But once again, for a typical data science projects, we have to have the import first, which is covered in module 1. We will cover the data, using this data table package, and then we need to do the tidying up and transforming that is done through the module 2. We have a separate notebook ready for that, and then we'll do a very basic exploratory data analysis EDA, that is just to observe how the data is looking like. And then we have to have a component or module for visualizing some of the data through ggplot2 package. As I have highlighted, these package names, tidyr, deployer, they are very much useful package, and you can say they are the state of the art, and they are the most used packages for any go-to R science project. And we have ggplot2. This is also, ggplot2 has become a package that is you can say it is status quo. It is it's a language, or it's a grammar for visualization. You can say if you are very much familiar with ggplot2 package, you can dare yourself to visualize anything in R basically. So let us go inside the Google Colab. And now I will quickly open the Google Colab main URL first for you here. It looks like once I'm opening it, it is here. It is here for you. I'll put it here next to me, and for our convenience, I will use this whiteboard to explain you anything which might need to be done through the scribbling. So this is the overall contents. We have this first just to give us a basics, which is a module 0, you can say. We click this, the first module, that is module 0. It's not the part of module 1 or 2. I will just quickly show you how we can load our required packages for this environment. Some packages that we will be using, it is not loaded, so we will be installing them. So the way we can install multiple projects is through this command, install.packages, and we are creating a vector package name. So write Excel, XML, RJSON, they are the package names that we will be using for this session, for different sessions, by the way. And then if you want to use a particular, if you want to install a particular package, you can simply type one of them Here I'm installing everything as a batch of the packages. So I'm just putting them as a vector. So you can even do that. And once they're installed, you need to load them in your session. So this is the way you are loading all of them. Some data structures that are that we will be covering here: a data frame versus table. So table is a data structure that is not shown in the slide, but it is a very advanced one on top of data frame. Whatever you can achieve through data frame, you can still achieve through table data structure, but table has some extra benefit that you can do. For this session, when we are going to use when we are going to see which current directory you are having, so you can just type get wd. So get wd, and then you can run it. It will show you. So let me manage my session. Maybe some other sessions are running, so I will close all of them because I'm running on limited resources. So I will be sometimes it complains if we are running multiple sessions at once, because it's a free version, so it will not allow you to do many things at once. So if you just run this whole cell, whatever you are writing here, you can just run them as a batch. So it is running now. It will show you where you are currently at, content/content. So before, let's say I have a data. How can you open such Google Colab? I will quickly show you. Let's say we are going to drive. This is my drive, and this is my drive here. And I can create new, and then go to more, and then I will create a Google Colab here. So yeah, if I click it, I will have my own session loaded. You can even try, if you have a Google account now, you can even try now. This is a brand new Colab notebook that you have just created. You can just name them here. You can just click it, my notebook. And what you need to do is, by default, is very important. By default, this notebook has Python runtime here, but you can change it to R. Just click runtime and change to runtime type, and we select here, and you choose R from there, and you just save it. That's it. Your runtime is now converted to R, and you can even run this by typing this function to get a working directory. Hopefully it will allow me to do it because I'm running another session. Yeah, so it has shown me that I am currently located in /.contents. Where is the /.content is actually here. So if you click files, you'll see this is your content folder. Okay, and in the content folder, you can you see there are some sample data loaded here. So you need to work on it later on. So let me go back to my first module here. I am going to create a data frame. So I have written the data.frame as a function name, which is this is a function that is already available in R. You need to write it. So I am creating a column that is called group, and I will have four values, A, B, C, A, B, B, C. So they are the values, and the second column is value. So when I'm creating them, I'm saving them in a df variable, and I can see what is there in the df by putting just df as a single value there. So it will create it, and it will show you here as a data frame. So you can see it is showing that first column is a character data type, second column is a decimal data type. So so this is basically a table now. Okay, this is a table. So this is the first row, second row, third row, and fourth row. All right, so that's the very basic syntax for creating a data frame. And how can we convert them as a table? So table is also similar syntax. As you can see, the table function is available through a table package, which is available in tidyverse. So tidyverse is a compendium or consortium of multiple packages. So I would recommend you to install this tidyverse, and if you load them, they will be available for you. So all the packages like table, data dplyr, or other related package will be installed there automatically. If I just show you how to load them, so see here, multiple packages are there: dplyr, 4cat, ggplot2. You don't need to install separately. Tidyverse has all of it. IDR, which you also use here in this case, and they are there. So you have loaded them, and you have created the table. And then you can even convert your data frame that you have created here. You can convert them to as table as a function just to convert their type. So both of them are available. So that's the quick basic of our how we can create the data frames, because it will be important for our further steps. So let's go to our first module. Let us leave this page. First page is how we can import and export the data using data table package, and it is also available in tidyverse packages that I have mentioned before. Let's go to this Colab link, which I have created. For the sake of our time purpose, I have written these modules a priori so that we can just run them and quickly show you. Because if I'm going to type all the syntaxes right now, it will be a long time. So what we can as you know we can aim out of this module is that we will show you how to read or write a structured data, which means the tabular data. Sometimes we have semi-structured, that means it's not properly have a tabular form, but it has a tree form. Tree means you have some data, it has hierarchy, right? Some data variable has parent variable, and so on. So they are semi-structured. Sometimes we need to read data from the databases. So this one is challenging. We will show you there later on when we are going to import data from the databases. But as I said, data could be from local file, could be a remote file, or could be streamline. I mean, it is through some streams. You need to be you need to be accustomed with any sort of data that you might need to import. And yeah, as you have said, three types of data structures are there: structured, I mean tabular. Sometimes it could be semi-structured, or sometimes they don't have any structure, like text or audio or video. They are unstructured data. So we can use firstly, I would show you how to use how to read Excel files, because Excel are one of the most important tabular form that we will use. So we can import Excel data files through read Excel package. So read Excel package is also available in tidyverse uh, package of content compendium, package compendiums, I hope. And through if you use read Excel / example, this function is basically a function that will make you to read example data that is available in this package. So you don't need to create the data by yourself. Just put a data set name there. This data set is available in or inbuilt in read.excel package. And when you are reading read.excel function, that is basically loading or reading the whole data or data frame in this one. So these two are these two syntax, you are loading them, and you are loading the package, and you are loading the data here. Remember, this line can be changed to your own data frame or the data file that you are going to load it. And this is the example is your variable that you have created before in this first past line, and this is the function that is actually loading your Excel file, and you are saving them to a data frame called df. And you want to show the first 6 line of the data set. Okay, you can call it the call through the head function. One thing I have forgotten while I was discussing the module 0 is this particular syntax. It's called pipe. So pipe is a very handy tool or very handy operator for your our syntaxes. So what it is happening is that we can call a function. We can call a function. Let's say I have a data frame. Let's say I will load a default data that's called iris that is available here. And I would like to show the head of this df. Let me show you. Save it in a df variable, and I can see the first line of the head df through head function. Okay, so it will see it is complaining now. Let me close it. Close. So if I library deploy package is loaded. So it is now okay. Let's do this directly. Yeah. So here I'm loading this example and I'm showing you I'm going to show you the head function. The head function is showing you the first 6 lines of the iris data. Sorry, the dataset Excel file that we have. It is saved in a df variable, but you can do this. If I just make these lines as comment, all these things as a comment, I can do that like through this way. Head function. Yes, so head function can show a similar thing, but what I am doing with this pipe operator is that, okay, head function requires an input and I am passing that input through my pipe to the head function here. So both way it will work. And why this pipe is important, because it is read it is friendly to read which functions is done first and then second and so on. If I want to show you the number of rows that we have, the number of rows that we have, I would run nrow function. So nrow function it will return me the number of rows that we have, and n the number of columns that we have. Even we can print the column names of the data frame. So if I say that, okay, I would like to do like this. So I have, let me comment it. I would do two-step operation. First, I will read the head of the data frame. So which is the output is just a data frame with 6 rows. But I would like to know what are the column names are there. And I would like to check the number of rows are 6 or not. So nrow would be the function. So I would expect here as a 6. So let's see whether we get 6 or not. 6, because by head by default it has it reads you the first 6 lines. Okay, so what I'm demonstrating here is that this pipe function operator helps us to see which like if we want to do sequential functions all at once, we can use one after another. So this value would be inputted here, and then the output of the whole function will be inputted in here. So it is like feedback, feed forward. So the output feed to the next step. So that's how it works. All right. So now, if you want to write Excel file, something to Excel file, you need to load this write Excel package. Hopefully it has been loaded already. So you need to load them and then call write Excel function. And the data you can even do like this df, and then I remove this this input because I have already by pipe operator I have feed my function with df here. So I would let me comment this one out, and the data that I'm reading from the loaded package, I will save it in Excel file, and where it will be saved I will show you. So this Excel file is, we need to load it, so that's the problem. Because when you close a session, it automatically removes everything. Okay. For that, let me install it here. Install the package. So the reason so it is now loading. Yeah, done. So I will show you the same code. Yeah. So this file is saved to my local directory, where I am now. Is my local directory is here somewhere. I'm going here. Okay. Yeah. So this is my current working directory. So if I get the current working directory here, I get, this is my project that I'm currently working, and this is my working directory, and that's where this temp Excel file has been saved. Okay. So remember, when we are where we are in our current working directory, your file will be saved there. So I couldn't show you here because every time I'm running multiple sessions, it kicks me out of the runtime, so I need to install it again. So that's the problem with these free versions, but it is good because I can show you stepwise things. Now, if you need to read a CSV files, you can call this import this data table, and the fread function can read the table for you, not the read.table. Why I'm showing you through this data table function, data table package, because fread is a function that can read a very large file very quickly. So it is good to, if you are familiarized with this function name. So if you read them, and you can read the whole file. Even you can read a remote files. For example, here this file is saved in a remote directory, so remote in a location URL we have. So we can read this file and we can save them in our remote df.csv. So let me comment this first and show you how fread function works. So if I load this, this is a message that is shown when you are loading the table package, and this is the data table that we have loaded from the file that I have in a directory which is saved here. So you have a sample data slash content, and I have a sample data. I have a file called California Housing Train. This file is in my location. I'm just demonstrating you how we can read a file with this file path. And if I show you how the remote function works. I mean, if I want here, I will open a file that is saved in remote directory using read.csv file. By the way, fread function also available for the same purpose, but it is a CSV. It has to have a proper URL. So if I read it, and then I will try to save it in my local directory. So let me do it. So it is done. Let me check whether I have remote.df saved in my content folder or not. See, it's remote/_df. It is saved, so you can download it. You can download it, and you can see whether that's really the file that we are, yeah. So this file has been downloaded from internet, and I have saved it in my local machine. So where we are. We are in here. Now, next thing is to show you the reading semi-structured file. Example of semi-structured file, a JSON file or XML file. So here I need to use I need to import our JSON package. Once again, I wonder maybe I need to install it again. So let me install it here quickly in our studio. Install the packages. What I'm going to do is that I will type our JSON. Maybe I need to use another package called XML2. XML basically. XML. Just let them install it here, and I would demonstrate you the how this JSON files are structured. So JSON files are like this, that you have a file, a root of a column. So let's say this is my ID, and then from ID I have two children, right? So two children, some other names like first name, a last name. So these data are basically organized in a structured format, and finally the end are the data set that are saved. So if I need, so this is not a tabular form, as you can see, this is a tree saved form. So if I need to read some file from some JSON file from somewhere, let's say from my remote directory or so on, I can install it. I can read it from that file through from JSON function, and it will read the data in my JSON data variable, and I can print how the data is actually looking like. XML has similar form. You can read the XML file through some package here, some link here. You are putting the XML file link and read XML function, which it will allow you to read the XML file, and you need to process this XML file in order to show the content of the XML file. Then for that purpose, you need to parse the XML file in XML parse function, and then it will show you the textual visualization of the XML file. So here we have, let's say, if we want to read it, if we want to see whether it has been loaded or not, so this iris file is loaded here. So iris will be available in my, let me go there. So downloads, iris is somewhere here. Yeah, so I'll copy and I will save it here. Copy my path. I'll copy the file path here directly, and I will go here. I need to put a current like this, and then yeah. So this is how I'm showing you the content of the JSON file. So we have iris, the same data file that you have seen. We have here their original the content of the files, as we can see. Now, if it is XML file, then XML file is loaded in a remote file. So let us load these two packages first. Let's load these two packages first, and then we have copy. This is loading the XML file, and the XML file contents are shown here. So that will be our XML file reading codes. How we can do that? And if we need to read the data from the data, we need to light packages. So let us just try to load them here. They're loaded, and we need to call DB connect. So first, we need to connect ourselves with the database by using DB connect function, and you need to provide where this data set actually loaded. We need to, one second. So first we need to connect ourselves with the database. So we need to copy this whole thing. Let us just copy it and go to our code here. Click this. Okay, paste. It's not pasting. Now I need to, this database is RSQLite. I have saved it in my computer, and I will take the file names, and grab the file names, and grab the file names and the file path. I need to specify the file path basically where it is loaded. The file path is loaded here, and it will show me what are the tables available in this database. Next thing is to read a particular table. So some data is saved in a table. So I want to read this table. I want to read this table just like a data frame. I will save it to a variable called db.df. I have written some extra thing here, which is try catch. So let's skip that now for now because it is something advanced, which is called exception handling. We will not cover this in this tutorial, but the overall syntax is to show you how this table can be loaded. See, db.df is now loaded. Now I will see the head of this table. Yeah, this is how the table looks like. We have a columns and we have a rows are available there. Even you can see here from this view function. So here it is showing you the whole table through RStudio. And finally, don't forget to disconnect yourself from the database connection. So we need to close it. So we are disconnecting ourselves from the database connection that we have initially established. All right. Yeah, so that's the end of my first module. And for you here, I have exercise. First thing is that, okay, we have a table hosted in a remote URL. First thing you need to do is to load this table, and you can, once you are loading this table, then we need to print the number of rows and the number of columns and print the first 10 lines of it. These are the tasks that you need to do, and then print the column names of the data sets. So I can copy this link. Let me copy this link for you and then try to paste it to the. Do you have a chat option, sir? Yeah. So I'm putting it in the link chat box. So you can copy this URL and then read the table using fread function or any other functions. You read the table and then save that as a data frame variable, and then show how many rows are there, how many columns are there, print the first 10 lines, and print the columns of the data set. If anybody has been able to do it, let me know. I'll give you a few minutes to do it, inshallah, and then I will ask from you what is the output. Is there anyone trying it? Otherwise, I will quickly just show you the tentative solution. Here, I don't want to show you directly, just I'm hiding it. I wanted somebody to try, but it's not difficult. Let's say that you want to read it. Let us read those libraries first. Why I have used dplyr? Because I want to use this pipe operator to show these things as concisely as possible. So otherwise data table package would be allowing us to read this through fread function, and I am passing this URL that I have provided to you. So this is just reading the whole data frame, and you convert that to a table, and you are just reading the column names. So let's quickly see what is the output. Yeah, so these are the column names that we have. Basically, this is a data that is the data set or data table coming from QS University Ranking. I have downloaded that and then I have make a table and hosted that to Google Doc. And this is the column names of this table. And I quickly let me quickly show you that table here in Excel. So yeah, so this is the table that we have. Okay, and for this purpose, for our convenience, I have removed some row here for you so that we can further reuse this table. So that the link that I've sent to you, it is just having this table form. So you can see these are the column headers. Okay, 2024 ranking, and the institution name, the country, and so on, their academic score, and their everything. So yeah. So let's go to our next module. So once again, you can see the whole module in GitHub as well. The GitHub link is also provided in the slide. In the slide, you can go to GitHub, and then yeah, in the GitHub, I have hosted this particular tutorial, training session. So all the modules are there, and the data set that I have used, I'll upload them here as well. Don't worry. The 2024 data set, the QS ranking data set will be there, and we have a main notebook. You can copy that, and then you run on your own machine. Everything is there, and we have. If we go to the modules folder, we have all the modules that we have listed. Okay, so going back to our second module, let us close it and go to our second module, module 2, which is data wrangling and cleaning through Google Colab. Okay, so in this module, we have a set of tasks that we need to perform. Let's hope that we have a data variable or data frame or table. We need to reshape them. We need to subset, or we need to do selection of particular columns, and we need to perform some statistics by grouping and summarizing. We may need to create new column. We need to merge multiple data sets. We may need to do some set operations, and we may need to perform some missing value handling. We'll perform that here. Let's say we have a tidy. So iris is a data that we already know that is loaded in our package. So what we can perform is that here we are showing you the basic of the data set iris. So loading this through a tidyverse package, and it is reading the table as a table. So iris is a data set that is already here. I'm saving it as a table, and I'm showing you the head once again. So you have seen this. It has column name called sepal length, sepal width, petal width, and species. 5 columns it has, and the last column is a factor because we are showing the head of it. We are not seeing all the columns that we have here. But if we show you the column names already by putting call names function and then run it, you see only this one are there. By the way, the previous text that we have seen before here, it was some warning message when you are loading the tidyverse. Second time, it will not show you. So these are the column names that we have in a vector form. Now, the next thing you want to do reshaping. For example, you have a data frame. Let's say you have a data set that has like the multiple columns, right? Column 1, column 2, column 3, column 4, and some column is your ID or pivot column, let's say ID, and you have, let's say, your grade in course 1, C1, grade in course 2 and course 3 and course 4, and also like that. So you want to convert this table, it is a wide form because it can have multiple columns like that, and you want to create or transform or reshape that into a long form. And long form means that, okay, I would have only ID, and I will have the course name, let's say course 1 or whatever it is, course name, and then the values that we have in this case. So basically what you have here, I will transform this in a pairwise form, so ID and course. So here I have the white table that has time, x1, x2, x3, and x4 are different columns. If I quickly comment it out, and then I show you the data, the glimpse of the data, white, the data frame. By the way, this dot doesn't mean anything here because in R it doesn't have any significance whether you make dot, because in Python dot means that it has the child attribute of the previous data objects, but here it doesn't mean anything. So yeah, I have created this white table, and it has 4 columns: time, x1, x2, x3, and x4. What I'm going to do, it is a wide form. I'm going to convert that to long form. So if I want to do long form, let me show you what is the table here. Table dimension here. Dim is a function that gives you the dimension of the whole table. You can just see there are 3 rows and 5 columns, which is exactly, they are the columns, and we have 3 values. By the way, asDate is a function that converts a string to a date form, and you are adding some extra value into the date, which is you're adding 1, 2, 3 just to make a sequence of or vector of date values. Okay. Next thing is to convert that to long form. So what we're going to do is to call the pivot longer function. That means we had a wide table and we want to convert that to a longer table, I mean long form, and we're calling this pivot longer function from tidyr package, and we need to put this as an input function. By the way, we can even do this like with a pipe operator and remove this. And next thing we're putting is that, okay, we will leave this time column away. So what we have here is that we have here, let me show you as what we have. So we have here time in our wide form, and we have x1, we have x2, we have x3, and we have x4 as for multiple columns. And I will leave this time column out, and I will transform all the x1, x2, x3s as the as one of the things that is called stock. I'll name a variable called stock, and then this is my value column called price. So what will happen is that I have a column that is not mentioned here, which means it will try to convert all the columns except time columns. That's why it has mentioned as minus. And the remaining one will be converted as or considered as the pivot column. So the time will be a pivot column, and for each of the time that we have, we will have time and x1 corresponding value, time of x2 corresponding value. So they will be sorted in a arranged in a one after another rows like this. So you have time, first column, first time, and then you have x1, and it has a value. This value, which value? This value. This value will be here, and so on. Time 2 x2 will be here. So this way you are transforming all of this long format into this wide form data into long form. Okay, so the vice versa. So let us see the let us see how it looks like now. Once we are converting to the long form, then the long form now is 12 by 3. So that means we had how many data? 1, 2, 3, 4, 5. So we are counting this number, these values only. We had 3 rows and 4 columns. So that's why we have 12 row. right? So you see X1, X2, X3. So this is the way we are organizing them in a long format. Once again, we are just manipulating or reshaping the data set, or reshaping the original data frame to long form from the wide form. But even you can do that opposite, which is if I want to convert back my wide like long form table that we have done here, we can convert that back to our wide form. Okay, so what you're going to do is that I'm using this input, this data as an input to this wider function. Pivot wider function will convert the long form to wide form, and you need to provide the names from which column it will be used for the names. So stock will be used, all the stocks that we have, X1, X2, X3, they will be converted back to the column names here. The values from are the price, but the time it will be automatically added is as a pivot column. So pivot column doesn't change. You can even change that. So you can even select the stock as a pivot column, and you can select T1, T2, T3 as different column variables. And the price will be your values here. So you can see how it looks like. Let's comment this out, and we see two outputs showing different things. So one is you are choosing the name from the stock, which is X1, X2, X3. That's why you see they are converted to the new column, and the date was this pivot column. But here, the next example, the pivot column was the other one, which is stock, but you are using different tables, different date as different columns. Okay, and the values are from the price column, which is we have seen before. So hopefully it makes sense for this reshaping. Next thing we can do is that we can expand some things. Expand means, let's say we have a table that we want to perform all set of all pairwise combinations or further values. Let's say this is our table. For example, we have a table here. DF we have created as a table. We have 3 columns, X1, X2, X3, and we have A, 1, 3. So this is the first row, second row, and third row. Here we can see A1, 3 is available, B1, 4 is available, B2, 3 is available. But if you want to expand X1 and X2 column, and I want to make all pairwise values, A1, B1, B2, what is missing? A2 is missing. So if I want to expand to these 2 columns, then I will see the output will be from here. I have 4 columns. See, I'm adding extra column, extra row, which was missing here. So we are expanding the X1, X2, all pairwise values as their corresponding rows. So A1, A2 was missing in this table. So we are creating that here. And then if I want to perform complete means if you want to perform the complete ones, means that okay, I will make the third columns also available. For that purpose, because we didn't have any values for A2 in the original table, it is missing value now. So that's why when you make the complete ones, the NA is introduced for the other columns. The next thing, we can collapse multiple columns. For example, table 5 is inbuilt data set. Let us first show what is the table 5 looks like. We had a country column, we have a century column, we have a year column, and we have a rate column. Now we would like to mark or collapse the century and year to make a single column that is called like 1999 to 2020, like this. So what we will do is we will call unite function. We will call unite function. We'll call unite function that will merge century and year, these 2 columns, and I make a new column called year, and I don't make them. I don't put anything as separate, so I can even control the separation. I'm not putting anything, so that means 1999 they will be together. So let's just comment it so that I can show you the next line as well. This will be new one will be see from. Let's comment this one out. Yeah, see 1999, and so I'm merging them as with a new column called year. After the output of this is done, I would like to merge country and year at the new year. Okay, the new column that I have created, I want to merge these two as well. So I will not only merge, but I will have a separation by underscore. So what I will see is this. So country underscore year, that is a column. So I have now two columns. Now this is uniting the columns, but what about separation? Sometimes some values are there, we need to separate them. So let us demonstrate that too. So let's say we have a table tree, which is also inbuilt. This is the table tree, country, year, and rate. I would like to separate the rate column by splitting these values with slash. So once we have this, we are going to separate them in wider form. So we have two functions, separate wider and separate longer. Separate longer is mean when you do the separation, it will make it a long form, just like this value, key value, and the like these are the first column, second column, and the corresponding value. This is a long form, and the wider form is for a pivot column. We have different columns available. So here, first I will show you the wider one. So if I just want to make wider, then separate columns will be created after separation, and the names that you should provide once you are separating. Then the first column that has name as cases, the second column will have a column name called pop. So if I run it, from this table, we have now there are three columns here. There are three columns with a rate. Now rate column has been now split to two columns, cases and pops. See 745. These are becoming one column, and the other one is another column. So if there was an extra slash available, you need to provide another extra column name so that it can accommodate the extra information. So there'll be three columns later on at the end. Now, since we have only two values separated by slash, so we are providing the separation or delimitation character to tell them that this is the delimitation values. But if you want to convert them to longer, then you have to call this separate longer delim function. So you see, you don't need to provide any extra column name in that case, because in this case you don't need to anything. So you see, Afghanistan, the years they are repeated because this value would be in the first row and this value will be in the second row. Okay, so that's how we will have their longer form. Now, sometimes it's really important to organize or arrange your table based on sorted order. So you need to sort your whole table based on the given column. So empty cards is also already inbuilt data set. You don't need to import that. This is the data set that is available. I want to arrange this table by its column name called MPG. So let us first show you this. You'll hide the other things, and I'll quickly show you the dplyr arrange function that will show you the arrangement. So this is the table that is there, long table actually. So there's a column headers. You have MPG, cylinder, mile per gallon cylinder. These are all columns are there, and there are the car brand names. So I would like to arrange the column based on MPG. So default arrangement is from ascending order, so from low to high. But if you want to change this to wide, like high to low, you can use decrement function. So let us use that. So same data set, but the column that you want to arrange for this table, it is based on you want to arrange this table based on MPG column, but in descending order. That means high to low. Just call desk function. There's a descending function. It will be making you the arrangement based on the MPG by descending order. So we would like to show you here. It is now like sorted in a descending form. Okay. Sometimes we need to rename some column name. So would like to show here. So column name is now x1, x2, x3, but I want to rename it by using rename function. So old column names is x1, the new column name is new called 1. So if I show you this output, it shows you that, okay, previously certainly the column names were x1, x2, x3, but now we have a new call, new 1, new call 2, new call 3. Although these examples are very small, but rest assured that these small examples are really handy when you are actually going to implement some data science projects. And why we are discussing with stress all of these steps, because data wrangling is the most critical part of your data science project, because your data doesn't obey your command. It doesn't follow your desire. You have to make it happen. You have to make it customized so that it can feed your purpose. So sometimes you need these operations. That's why it's important one to learn. Now, sometimes we need to select a part of the data set. So if I want to select a particular row, I will call filter function. And I would like to say that, okay, some logic I should apply that, okay, sepal length has to be more than 7. And I will only select those rows. So iris is a function, or sorry, data set from where I would select the particular rows that is following the filter sepal length more than 7. So if I show you here, only this, the sepal length is more than 7 is only selected. None other rows are not selected. So filter function only selects the rows. Now, if you want to show distinct rows only, then we need to, distinct rows means sometimes some values are repeated. So the distinct columns are already, rows are already only selected. Sometimes you need to just click the samples of it, sample or some portion of your data set. Randomly you select 10 rows. So it will be selecting by using sample end function. So it will randomly select 10 rows from the whole data set. Maybe you need to select some rows from row number 10 until row number 15. So you use slice function for that. So it will extract the rows from row 10 and row to 15 for you. So how about selecting columns or filtering columns? So you can use select function, and you said that, okay, select columns from my iris data set. Maybe so if I do that, then I get the whole data set, but only with the 3 columns. So I have 3 columns here. You can perform similar action by specifying that, okay, you select all the columns except these 2. So I am passing this column names as the vector, and I'm putting minus in front. That means discard these columns and give me all the other columns except these 2. So I get the similar thing. Petal width and petal length are discarded from iris, and it is shown to you. Remember, you need to save it. If you want to use this table, you need to save it for your purpose, and then you can do this later on. It is not automatically done for you. It's just showing you the output of it, but you need to save it for your later purpose. Remember that. Okay, so the next step is group-wise summary. It is very handy. What we have here in this iris data set is that the species. If I quickly show you the iris data set here, iris data set is its data set is, let's say, head of it. Iris data set has like the last column is factor, and I would like to group all the rows based on the different factors like setosa or other factors. I will group them together. So the rows will be grouped first, and then we would like to summarize all the rows with their like average. So this will be average, this will be average. So the group wise average will be performed, and it will show you the column. So we have how many columns, how many different values we have in the species. So if I would like to select dplyr now species, we can access them like this by the dollar sign, only that column, and you see the unique values. We have setosa, you have vesicular and Virginia, these 3 different columns. So you'll have three groups, and for each group you will perform summarization which based on the mean function. So you have to specify that. So let's comment it out, and then I would do this one. I would expect 3 rows with their each each values will be grouped by their means. So you see for setosa, all the rows that have setosa species, their sepal length is now taken as average, vesicular as average, and Virginia as average. So this is very important if you want to aggregate the whole data set based on some function. You can do that. Even you can perform summarize based on only particular column. Another column will be left as it is. So you can perform that through summarize. Other functions that are available for summarize, but I can't certainly go through all of them because you need to. That will take a long time. Just a glimpse how you can perform group-wide summary. Now maybe we need to create a new column. So how can we do that? Maybe there are some row names available. So let's say empty cards is a data set. Empty cards is a data set where you had initially. This is a long data set. I'll only show you the empty cards data first. This empty cards it's a data frame, but it has a row name as well. Now we can accommodate that row name into a new row, new column. How can we do that? Okay, so let's do this here. I'm using this empty card as an input, and I'm calling the table row names to column function. So whatever row name we had, we will create a new column called C, and then we'll see what is the output. The output is now C is now provided here. C is now provided as a new column. The no row names are now vanished. Instead of that, we had a new column there. You can perform the opposite thing as well. You can perform the opposite thing, which is, let's say we have done it, and now we want to get this column name back, column name to row name. So whatever column I had C, I would put back to make a new row name. So which column I will choose for the row name? C. Okay, and then I will see what is the output. See, now whatever we have created, now C is going to go back to its row names, just like that. You can combine multiple data sets, multiple tables by using join. This requires us to understand some bit of database concepts. So we have two tables. Let's say first of all we have two tables, and these two tables are looking like this. Table 1 and table 2. We have A1, B2, C3, and we have other table A, true, B false, and D false. Two tables are there. Both of them have this dimension 3 by 2, 3 by 2. Now what I will do is I will join these two tables by using a logic called left join. Left join is something that, okay, I have A here, A table, and we have two columns, X1 and X2. In my data frame A. So X1 is A, we have B, and we have C. X2 is 1, 2, and 3. And then second data frame B has another two columns, which is X1 and X3. We should be careful about the column names because the column names will be used to do the merging. The values that we have here is A, and then B, and then D. And then we have true, false, false. So if we want to do perform left join, it will check the column names. Do they have similar column name? We have, yes, we have column name that is based on X1. So we are specifying based on X1, we do merging. Whatever value that you match, A and A, they are matching. So for A and A, you can create a new join. You need to join this. You can create a new join by having a data frame, new data frame that will have X1, X2. Left join means whatever you have in your left table, which is your left data, which is your first data frame here, A. Whatever you have, you will persist with whatever it has, A, 1, B, 2, and C, 3. But you are adding other columns from the B, which is X3, the one that is matching. So A and A matching, whatever content you have it here. B matching, B2 here, B2 here, so it will be F here. And C is not there. So if C is not there, what will happen? So it will, as I said, left join will allow us only whatever we had for the left table, it will be sustaining there. If any value is missing there, it will be NA. So let's see what we have here as an output. The left join, we had A, B, C, and C, we have NA for the C. Okay. Right join is just opposite. The right table will be persisted, and the values for the right table will be matched based on this matching column that we have provided here. The column that we should say we should use this by that column. See, yeah, so for B, A, B, D, so this table is persisting, but D was missing here. So since D was missing, I mean, X2 column will be NA. Inner join, it means it takes select only those rows that have matching. I mean, it will discard the NS. I mean, it will remove these NA things. Only A matching, B matching. Only those two will be selected. So we see only 2 rows will be there for inner join. Yeah, only 2 rows are there. There will be no missing cases. And full join means you will merge both of them, whatever it requires, whether it requires any NA to be introduced, it will do that accordingly. Okay, so it will do the full joining. So the total number of rows will be the union of all of them. Set operation. So set operations are important because if you want to do intersect between these two things, these two data table, it will intersect based on the matching rows. The rows that will appear in both data frames, it will be selecting them. Union, it will merge, make the union of the rows. Set diff, it will select the difference. That means the rows that are available in first data frame, but not available in the second data frame, that will be outputted. And bind rows means it will bind these two. So I will quickly show the bind rows, how these bind rows are done. So the rows of the first table and rows of the second table will be merged. So column names will be renamed, but the column number of columns should be consistent. I mean, they should be the same. So you are adding whatever we have this as these 2 rows. 1, 2, 3, 4 rows. That will be 1, 2, 3. So these 3 rows will be added and after these three rows. So we have bind columns means we are binding column wise. So let's see. Now we will have 4 columns instead of 2 columns. We have 4 columns. Now the columns then will be renamed based on their sequence. Remember, we need to rename the columns by using the rename functions that we have done before. Now handling missing value. Let's say there are some data that the data frame that has missing value. Let us quickly show you the X. What is X? X has a missing value here. We have a missing value in 3 rows. What can we do? It is very common situation. Maybe we need to drop all the rows that has NA in X2 column. Okay, so you need to provide which column you should focus for finding NS. You need to drop all the rows. So drop NA is a function that will drop all the rows that have NA. So firstly, we had this is initial data frame. Now we have only 2 rows. Why? Because we removed this row and this row and this row, because X2 column has NA in those rows. But maybe sometimes it is very harsh. Now we can impute those rows by filling X2. But with what value we need to fill? Okay, there are a couple of techniques, and I said this is very intelligent language because it will automatically consider some value from X2 column and it will fill the missing values. Let's quickly see what we have here. So it is filling this. See, second row was what? Right, but it is putting 1. Why? Because it is considering it's in a previous value and it is putting this value in the missing places. It can also, it is the default thing is going downwards. That means whatever its previous value is, it is putting the copying that data downwards for all the missing values. So that's why 1 and 1 is there. And this was missing. So the previous value was 3. That's why it is put at 3. Remember, it can be customized. That means we can put downwards like upward as well. So whatever you had as the bottom ones, you can put them back here. So it's controllable. Sometimes you need to customize based on you can replace all the NS with a fixed number. So in the X2 column, all the missing value, let's replace them with a fixed number 2. So you see the value will be, all the missing value will be 2 here. Okay. Exercise for this, whatever you have done in the previous module, you can you need to perform. Then you need to perform what? You need to select or only select those universities that are in Saudi Arabia. And then those outputs, you need to order them based on their faculty rank column in descending order. So since we have time restriction, I would quickly show you what we have done here. We will be showing you that this is the data frame that we have loaded, and we are filtering the country code based on Saudi Arabia. SA is the country code. And then we can arrange them in the column that is based on descending order of this international faculty rank. So once you do this, you see the international faculty rank. You see King Faisal is coming at the top. Okay, King Faisal coming at the top. And if we change this to yeah, so that's the output that we get. I was hoping another university to come top, but yeah. So Imam is the number 3rd based on that column. Okay, so that's our exercise for module 2. So let's close module 2 and then go to module 3 for exploratory analysis. And we have a couple of steps to perform. Now we can quickly show the summarization of the data set by calling the summary function that will give us a whole summary. The str function also gives us the similar output, but it gives you the object description of the whole data set. You can check the class of each column in the iris data set by using supply function. What it will do is that it will consider the iris data set, and it will go through all the columns and perform the class function to check its type. So if we just show you that, then let us close this. Oh, we have forgotten a syntax. Oh, okay. Yeah. So it says that firstly, it is showing the summary of these two data sets, also string form of this. So summary, when we are calling summary function, for each column, it is showing a minimum value, first quartile, median, mean, third quartile, max. This is the statistics that you get for each of the columns, column-wise. Okay. You can even do this for the first column as well, only the first column, which is iris semicolon. Let's say MPG. For this column, I would like to see the summary or the summary statistics. So I get minimum value as this, first quartile as this, median as this, and so on. And if you perform this for the whole data set, then it shows you the column-wise summary. But here, supply function, it is you're applying a particular function on each of the column of this iris data set, which is class function is what you are having their column, the class. The class is all of them are for example, for all of them, for this column it is numeric, for also petal width is numeric, but species is factor. So it's showing all of them as a statistics. And number of rows, number of columns, dims, heads, tails, they are also important statistics, because I would like to know how many rows are there in empty cars data frame. Also, number of columns is the number of columns for in the data set. Dimension will show you the similar thing, and a dim will be giving number of rows and number of columns with the space. Head, we have seen this before. Tail means the tail part of the data set, but you need to control the number of rows that you want to show. So it will show you the bottom 2 rows, and head will show the top 2 rows. Some measures for central tendencies. You can check the mean, median, or variance, or standard deviation, or interquartile region, range, interquartile range, mean, max, range function for each of these columns. So this is a vector. For all these vectors, you get these statistics. You can get the table of form as well. So let us Let us comment this one out and quickly show you the output here. Yeah, so this is the mean, median, mode for each of the columns that we have asked it to compute, IQ, range, and also similar things. And then we have a categorical variable. So for the categorical variables, we can convert them into table. Okay, so table function is something that can make a table form of the of this particular column. Sometimes we need to find only unique values for the cylinder column. There are the only unique values. And if I want to find out the first like quartile of the first quartile, second quartile, and the top quartile, so we can do that. So firstly, check that okay, R norm is a function that is generating 1001 values from the normal distribution, and I would like to show the quantiles of it. So it is showing different quartiles, like 0% is this, 25% is this, 50% is this, 75%, 100%. So it is showing me all the quartiles. You can even control the quartile probabilities. So you can get these data values. For example, if I do it, I get different quartiles that I want. And if there is any missing value, I can check whether how many missing values are there in a table. Let's say I have this table in my subdirectory, and then yeah, the value is not available here. So we need to import that housing price. I'll drag and upload this because every time the session is ended, it forgets about the data that we have uploaded. So I will save this file to my sample data directory and I run it. And I know there are missing values overall in the whole data frames. How many missing values are there? So it will check is NA. It will produce true false for each values in the table, and it will count how many truths are there by some function. So total, it will give me how many missing value I have in the whole data frame. Even I can check for a particular column. This is the column for the DF that we have here. For this column, I can check the number of missing values I have by calling is NA. So is NA function will basically give me number of true false. If I just quickly show you this, see there are a number of values we have the LA. So for each of them, the true false is applied whether it is NA or not. And I'll just count how many truths are there by calling sum function. So it will give me a total number of missing value, which is 1369. Lastly, very important thing, sometimes we need to detect outliers, and there are some algorithms for detecting outliers. That means there are some threshold values that should find out that okay, some values should be 1.5 times IQR, and less than that Q1 minus that basically the logic of that threshold would be considered as outliers, or more than Q3 times IQR would be also called outlier. So this is an algorithm to detect some outlier values in a given vector of values. So we can check whether there is an outlier there or not. If there is an outlier, how many outliers we have. So here looks like we have 3 outliers in this whole column. Which is air quality is a data frame. Once again, it's a data that is already loaded in our session, default data. And I'm looking into the wind column for it. So wind column, in the wind column, I check whether there's an outlier or not. So let us just quickly comment out the other things. And I select the first 3, Q1 and Q3, like first quartile, which is 25%, third quartile is 75%. And then I determine the IQR based on IQR function. And I did define that, okay, if the value is either more than that and also less than that. If it is the case, they are not they are not outliers. But the outliers, there are outliers, they are not following that logic beyond that. Okay, So any value that is falling inside is based on within the IQR box. Putting not means let's just exclude them that are not there. So subset function is basically extracting from the whole data frame only those values that are not following the logic, which is beyond this. So we are choosing how many of them are there. So subset outliers are basically, this is the table that is showing these rows are those rows that had win column, which are called outliers. So they are either less than the first quartile, like outside of the first quartile, or more than the fifth quartile, like third quartile. So I would just show that there are 3 of them are there. So once you are getting the outliers, you may need to deal them accordingly. Now, the correlation is very important. We can check the correlation between 2 vectors by using core columns, a core function, COR, and you can provide which method you are using, Pearson method or Spearman method or Kendall's rank method. You can call core function and pass these 2 vectors, first vector and second vector, and specify the method. And you can even do the correlation test to see their significance. So I will quickly run it, and I will show you the Pearson values for each of the correlation value between these 2 columns, WT column and MPG column, and the different method has been used, and their corresponding correlation values are shown. And you can even get their significance, whether it is statistically significant or not, based on the t-test, which is done through core.test function to test its significance. Well, I would exclude this clustering because of the time, but you can have the code there, you can run it, but you need to install these 2 packages for that. And that was the last step. An exercise for you is that, okay, for the same task that we have been doing, you can check the correlation between these 2 columns, whether they have or not. So I have a solution for it as well. Look, this is just what we have done in previous task. The next thing is the new thing is that just running the core function on these 2 columns. Look, this column has not been properly formatted. That's why I am parsing it to numeric, because in the data set it was considered as character. So I need to convert them to a numeric, because for calculating the correlation coefficient, you need to use the numeric values. So I am modifying my data column to numeric values, and then I'm running the Pearson correlation function to run it. So it will show me some correlation value, which is negative, but 0.09. That means there is no correlation between these 2 faculty rank and faculty research networks. We don't have any correlation in the universities in Saudi Arabia. So that's the 3rd module. The 4th module and the last one is the visualization. For different visualization, I will use ggplot package. Firstly, you need to load those ggplot package. Let me close this. Okay, let's first load it. Firstly, we can plot the bar plot. The bar plot is, firstly, you need to load them, and we have a data frame that has 2 columns, name and value. And if you want to make a bar plot, firstly, ggplot function is the function that loads the data, and you need to provide aesthetics, which is what will be your X column and what will be your Y column. And you are creating the bar plot. So once your ggplot object is created, you can customize what type of plot you want it. Geom bar is the bar plot, and you can run it. Stat identity means whatever value directly you have in Y column, you just use them accordingly. You don't perform any statistics on it. So this is how you have simply created very small code. You can create a bar plot for that. If you want to create the histogram, I'm reading a file from the remote file, and I'm creating the histogram. But before that, the data that I'm loading, I can perform some filtration on it, and then the filtered value will be used to create the ggplot histogram. For the histogram, you need to call geom histogram function, which is available in ggplot, and you can specify the bin width, and you can fill the color code, and you can even control their transparencies. And you can put the GG title, the title of the plot, and you can even control the different part of your text. So here I am controlling the bin size. The font size is I'm putting 15. I can increase or decrease that. So bin size, this is the text, okay, the plot title. So I'm controlling the plot title with the size here. But if I want to control the bin size, let's make it 4. I would see, I would see a different plot, which is having their bars slightly wider. Density plot, similar concept. I have a data for which I want to create density plot. I will call it geom density function. It will automatically make the density of this whole data value. Let's see the data frame that I'm creating. It has a it has 400 by 2 columns. So there are 2 columns. One is for female, one is for male. For each of them, I can create the density by calling the geom density function, and I'm creating the density plot for that. Box plot is for that you need to call geom box plot, and you need to sometimes the geom box plot you need to show the outliers. So outliers can be shown with a red color, and it has a shape code. Shape code 8 means it's a star. If you load it, then see this value for this particular column was outlier, so it is showing as an outlier. Violin plot, very similar to the box plot. So just call the geom violin as a violin plot. It is showing for each of the categories. It is showing their violin plot. Reach plot. I need to. I'm not showing this plot because I need to install that again. So otherwise, it will complain it. Yeah, so it's not loaded. But this is similar thing what we have seen for the violin plot. Scatter plot. Scatter plot is surely it is for it is you can do that for geom point. A geom point function, it will just draw the point for each of them. So you need to specify what columns that you need to use, X and Y. For empty cars data, I'm using X axis for WT and Y axis for MPG, and I'm creating the scatter plot. The scatter plot is I'm showing you 2 plots here, one by one, 3 plots actually. Firstly, I'm plots without any customization. Secondly, I'm customizing something, the size of the dots and shape of them. I'm controlling them. See, I'm controlling their dots. Also, I would like to show you geom smooth. So geom smooth means you are putting some band over this thing. So it is using the linear models to make some linear fitting for this particular scatter plots, to show that okay, the plots that the scatter plot that I did, the dots are showing some sort of linearity, and you have confidence bandwidth associated with that. Line plot, for line plot you call geom line function, and you can control their different types, or also the colors. So we can quickly see there. Yeah, so we have different lines, although it doesn't make sense here because we are properly using correct columns, but this is how we can show XY lines. Correlation plot. For correlation plot, I need to use GGLI. So let me check whether I have GGLI loaded here or no. Maybe I have it. Library. Yeah, I have it. So I can show you this code. It is basically a correlation plot. So you can show the correlation plot for all the pairs we have. So pairwise correlation for different variables. So variable 1, variable 2, 4, and variable 5. What is the correlation between this vector and this vector? If v1 and v2 is what? So you see v1 and v2 is this one, and then similarly they are shown as their corresponding correlation. So it is a nice visualization if you want to show the pairwise. But the correlogram, it is a scatter plot matrix, which is very handy and very nice looking. You can see there what they're doing is that for each pair. So if I zoom in, for each pair, variable 1 and variable 1, this is variable 1, variable 1. They have variable 1 and variable 2 has a correlation 0.526. Variable 2 and variable 3 has 1.146. So this is something you are showing, huh? And you are also showing their pairwise scatter plot, also the density plot. it's very important to show all pairwise things. So if the number of columns are not so much, you can control that accordingly. Heat map plot is good. It is showing you the heat maps of a whole data set. First one is not scaled. It is just like the raw data. But if you want to scale it, scale the columns, you can pass the scale function, scale argument with a column. If you want to do the scaling for rows, you put row, and then you get scaling and you get a nice visualization for this heat map. Lastly, the exercise for it is that okay. For the same exercise, just visualize the relationship between size and international faculty rank. And also you can just run it quickly to see. Yes, so this is the basically this is a bar plot that I'm showing for the size and the faculty rank. That's it. Sorry for rushing because I wanted to cover a lot of things and I know there's not much time for the questions, and still I would be available for accepting any questions you might have very quickly. Thank you so much. So we're not covering feature engineering or advanced modeling or dashboarding for this communication purpose because we don't have much time. But I try to cover most of the very basics of the data science projects. As you can see here, it will need an extra whole 2-hour session, even more than that to cover these things. So I'm purposefully exploring it. But I hope you got a holistic overview of a data science project through our program. And these are the model exercises. And yeah, I'll be open for any questions very quickly. Thank you.
We would like to thank Professor Akam Azad for the valuable lecture, and we truly appreciate his great efforts. Feel free to ask in case you have any questions.
Anyone has any question?
Any questions, please?
Okay, if not, still you can reach me via email if you have any question regarding this presentation or this training session. I'll be very much open to answer them. Yeah, I'm really sorry. I don't have a proper understanding of Arabic. I'm still new, so please, somebody can translate for any question for me if it is written in Arabic. I appreciate that. Okay, so that chat box needs. Yeah, I would like to thank you for all for attending this training session. This requires a lot of patience, I understand. And yeah, as I said, the GitHub repository is there. If you want to try them by yourself, let me know if there's any issues you are facing. I will be very much happy to respond to your queries if, within my capacity, inshallah. So yeah, thank you everybody for attending this training session. And yeah, hope to get any feedback out of this via email or any other WhatsApp messages, whatever means is possible for you. Thank you so much and these are the references. Yeah, I would thank you all for your time.
Thank you, Doctor. Thank you.
Yes, yeah, Dr. Naif has raised up his hand. Yes.
No, thank you for your lecture.
Yeah, I mean,
Amal Tairi, the coordinator of the lecture.
Yeah, I think Dr. Naif wants to ask something.
No, I think no, nothing. Thank you.
Okay. Thank you. Bye.